The last type of operation we're going to look at regarding Venn diagrams is the complement of B relative to A. So this is the set of all elements in A that are not in set B. So the way they denote it is, it looks like subtraction, A minus B, or you can think of it as A without B. But it's all of those things that are elements of A, but they're not elements of B. So they're inside of A, and they're also not inside of B. This is also called a set difference. This is also why the subtraction sign is called a difference symbol. So I think of it as all the elements in A that are not touching B. So basically you can't be touching any of this part of B. So what it ends up looking like, that little yellow part, it looks like a cookie with a bite taken out of it. And this says, I know it's teeny tiny, but it says A minus B inside there. So that is what your like subtraction looks like. So I say A without B is another good way to think of that. But that's the shape. So where the intersection is a football, the union is both circles, this complement is a cookie with a bite taken out of it. So let's do an example where we arrange some letters on the Venn diagram. So set A has these letters A, B, C, D, E, F, G. And set B has the letters D, E, F, and H. And they want us to find A minus B, right? So the complement of B relative to A, and then the complement of A relative to B. So we're going in both directions. So let's just arrange letters first of all. You always start with your intersection. So if there's anything that matches, like D, E, and F, and D, E, and F, I would put those in the intersection. So D, E, and F. And then A also contains A, B, C, and G. And now I've got all of A listed. And then B has D, E, F, and then it also has H. So now I've got everything listed on my Venn diagram. So the first thing I want to find is A without B. So think of it as A, the A circle, but we're not going to touch B. So I'm going to cover up the B circle. And it's basically that shape right there. It's A without B. So A with a bite out of it. So it's going to be this part right here, which just contains these letters A, B, C, and G. That would be the set of A without B. Now if we go the other way and we do B without A, that's the B circle, but we don't want to touch anything that's in the A circle. So we're literally going the opposite way. We're going this way. That's going to be B is the cookie, and it has a bite taken out of it this way. So it's just like that, like half of the B circle, which only contains the letter H. There's my little squirrely bracket. Oh, that looked terrible. Oh well, you get the idea. There is our little set. It only contains one element, and it's H. So another thing that you can do is you can start to determine if two different statements would actually yield the same thing. Like, are they saying the same thing? So we're going to find out if saying B minus A or B without A is the same thing as saying B and not A. That's what that would say. So I'm going to draw both here. This is going to be B without A, and this is going to be B intersecting A. Okay. So if I draw B without A, so I'm going to, it's like I've erased the A circle. It's going to be the B circle with a bite taken out of it. So it's going to be this part right here. All of this, if I can just shade all this real quick, right? So this is the area we're talking about. It's that B cookie with a bite taken out of it. So that's what B without A looks like. Okay. Now, if you want to draw an intersection, what you can do is you can do shading for one object, a different kind of shading for the other one, the other set, and then you look to see where they overlap, because that's what an intersection means, is an overlap. So I'm going to do this in two different colors. I'm going to shade B, circle B, in blue, right? I'm just going to shade it like this in blue. This would be circle B. Okay, that's all B. Now what I'm going to do is I'm going to shade not A. So I'm going to go the other direction. I'm going to shade it in red. Everything that is not A. So see the circle that's A? Not that. Everything else, but I'm not going to touch what's inside circle A. I'm going to kind of shade this way first. You realize it's going to go like all the way across here. All of this stuff that I'm shading red is not A. All of this is not A. Okay, all of that is not A. So then what you do is you look to see, well, where do you have like double shading? Where do you have like this cross hatching? Where does the blue that I drew intersect the red that I drew? And where the blue and the red intersect is right here. They just intersect right here. So I'm shading like the overlap. I'm going to say this. Where do they overlap? Well, the overlap is what I just put in yellow. So the question is, the answer to this picture is the yellow part. Does the yellow part here match the yellow part there? And the answer is yes, it does. So when you say these are actually equal, B minus A is the same thing as saying B and not A. It's like we've distributed the negative to the A. Do you see that? And we put an and symbol in between it. That intersection means and. So if you draw the two, yes, it does turn out that they're actually the same.